As Martin said, in 2.3 we wanted to start a major change in monitoring databases. And for this first step, we needed to decide which database we want to start with. And we eventually decided to make that MS SQL. But why did we do that? To explain that, let me take a step back. The plugin we used has been alive for almost 12 years now, and it was never prepared to be used in today's world. We at Checkmk, meanwhile, gained a lot of experience to do database monitoring. And on the other hand, we currently have a wide range of different plugins with different functionalities. Currently, general functionalities are spread across different plugins, so others do not benefit from them. And for us at Checkmk, it gets more and more difficult to keep them in sync. But there's one more thing that meanwhile became reality. Databases are not only on premises anymore. More and more users shift even their databases into the cloud. And here you cannot deploy an agent or an agent plugin at all. You need to monitor these databases from the outside. At the same time, the initial plugin has been extended with a lot of checks while sticking to the initial architecture, and it eventually became almost unmaintainable. Users like you run more often into performance problems or unmet dependencies. On our side, it has been a problem of maintenance, as I said. Less colleagues felt comfortable with VBS as a scripting language. But more in detail, you, the users, more often complained about missing features or problems like disabling sections, caching of sections with long-running SQLs, timeouts for all remaining databases to call if one in the middle takes unusually long. And on the other hand, our support had a very hard time as the plugin had no logging at all, a very confusing and hard to understand code, and this made bug fixing or new features very time-consuming and an expensive task. This is when we decided to take the chance and start from scratch, not only rewriting the MS SQL plugin in another scripting language, but make it a really good monitoring. And speaking of gained experience, over the last years, we learned that, beside of others, you need to have a very good solution for at least these three parts. A good and robust detection of databases, as well as the possibility of defining them on your own. Second, you want to have a flexible connection to cover different implementations and authentication types. And third, you want to have a flexible and optimal execution of SQLs, which includes control over how often an SQL is being executed. Let's talk about these three parts in more detail. Having a comprehensive detection of your databases allows you to monitor your instances without the need to specify each and single of them. So it's about instance detection. In the current plugin, we cover the SQL Server browser to detect instances as well as its original source, the Windows registry. Using these official resources saves you, as a user, a lot of manual configuration time, even if the database is located on another server in your network. On the other hand, sometimes it's not possible to automatically detect an instance for any reason. And for this case, you need a reliable way to tell the plugin which one it needs to monitor and under which alias to find a specific instance. Secondly, every database provides different types of authentication. And on the new plugin, we aimed for keeping the existing methods, of course, which is Windows authentication and database authentication. And at the same time, we prepared the plugin to be able to add others later on, such as token-based authentication. And in the end, everything authentication configuration, and the instance discovery needs to be put together to eventually establish a connection and fetch the data, or, if needed, cancel at some point if a connection cannot be made. Configuring timeouts is essential for both SQL and the connection to not get stuck and potentially losing follow-up data. For SQLs, you additionally may need to configure each of them, as some may take longer, and others are time critical and you need them every agent execution cycle, which is usually 1 minute. But while transferring the fast SQLs every minute, you need a caching interval for the others. And the new plugin for MS SQL finally covers this part and allows defining these two individually per called SQL. And it covers even more. In the example here, you get the active connections and blocked sessions in a short amount of time, while SQLs to get data for table spaces and scheduled jobs take much longer. And because of that, you will set a cache interval to these. Until now, you have not been able to set two intervals for two individual databases, as the agent just respects just one cache interval per section during computation. So you have been forced to consider the slowest database instance while defining the cache. And for the first time, the new SQL plugin is now able to place the data of each database instance to an individual host in Checkmk, no matter if the instances are running on the remote or on the same server as the plugin is running on. This allows you to set independent cache intervals for two database instances, respecting the individual execution time needed for each of them. You can see that on the right part of the slide, where you need a 10 minutes cache for the big core database. You can now lower the cache to 5 minutes for a much smaller database where you expect to get the results much faster. Another new part is the parallel execution of SQLs on several databases. And this is especially of interest if you monitor different database instances on remote hosts or in the cloud. In our example here, the plugin just runs 23 seconds, as this is the longest time needed across all three. Before, the plugin would have been run for 42 seconds, the sum of all three, and almost double the time. Thus, in the real world, you need to balance, of course, between putting your database on server not too much under load and fetching the data in parallel at the same time. You see, we already covered a lot of options and features to make these three parts possible and easy. But it's also about running the plugin itself. The old plugin just covered database instances running on Windows, and also just instances that are running on the same server as the agent plugin. And of course, this is covered in the new plugin too. But as I implied before, we also added the possibility of monitoring databases on server where you cannot deploy an agent on, including these on your internal network as well as these in the Azure cloud. And this is a very important step, as it enables you to monitor all Microsoft SQL Server instances in the same way, regardless of where they are deployed. And during development, we spoke about a goal to add support for Linux in the later Checkmk release and discussed about the challenges we are facing there. And I saw before that someone already raised a question about that. But at some point, I guess it was during end of last year or beginning of this year, my colleague Sergey surprised me with something that pushed this project way beyond the initial scope. And this is, you can now deploy the plugin on Linux too, to monitor the same type of instances from there. All of the same code base and feature set. Considering obvious limitations such as Windows authentication is only available if you deploy the plugin on a Windows server. But beside of that, there is no difference in the functionality between the plugin on Linux or on Windows. And this is already included in Checkmk 2.3. And from our ideas portal, we know, and from the question in the audience, that monitoring MS SQL on Linux is a long-wanted feature from you. To accomplish all this, we needed to completely rework the used stack, still using technologies that are already established in Checkmk. And for that, we chose the known YAML as a language for configurations. We added long-needed debugging options, and we implemented the plugin completely in Rust. But more in detail, to be able to map the previous shown complex configurations, we needed a language that is capable of having a hierarchical config design, allowing you to define individual options for specific databases, as well as defining standards to be used if no further is defined. And YAML is the perfect technology for that, especially as it's already being used in Checkmk at other places and a well-known language for configurations in general. And of course, you are also able to create the configuration file via the agent bakery, so you're not forced to write YAML if you don't want to. Secondly, as the old plugin had no logging or comprehensive debugging methods at all, both Checkmk colleagues in development and support, as well as you, our users, struggled in the past during investigation of problems. And as we are switching now to a compiled plugin, having insights of what is happening is a fundamental piece and covered with standardized logging now, both for you as a user, but as well as for my colleagues to help you. And all these parts are finally converged in a plugin written in Rust. It's almost as fast as code written in C++ and allows cross-platform compilation. The Rust Foundation already covers a lot of platforms and it's constantly extending the list. This and the fact that we are already gained experience with Rust and other projects in Checkmk makes it the perfect language to be used if performance is a critical requirement. And last but not least, it also does not require any further dependencies. But every light has its shadows. And this is also true for the new MS SQL agent plugin. When extending the functionality of a plugin in such a massive way, you need to balance between very basic and complex setups. And currently the new plugin is able to monitor complex setups much better or even at all. But very simple setups which do not have TCP/IP enabled by default are currently not covered, as the connection is admittedly simple but also not necessarily always reliable. And we are currently investigating how we can combine both, covering simple setups as well as providing a reliable way to monitor these. So our journey did not come to an end, but it marks an important milestone and is the start of a big step forward. So what's next? First, we will work on the coverage of setups not having TCP/IP enabled by default, as I said right now. And in the last days, we are already made big steps forward in this case. Second, the enhancement of our auto discovery will be improved, further improved, and the agent plugin configuration, which is the third point too. And finally, we are collecting now your feedback and prioritizing them to make it the best plugin for the relational databases. So now it is your turn to give us feedback and to tell us what you need in the future. This has been a lot of information in about 15 minutes. So let me summarize the changes in 2.3 for you for MS SQL. We not just migrated the existing plugin, to an up-to-date language, but we wrote a complete new plugin maintaining a fully compatible output to the old one. The new platform is both running on Windows and on Linux. You can monitor databases locally in your internal network and even in the cloud. The configuration options has been massively enhanced using the experience gained from all our other database plugins. You can now cache long-running SQLs to improve the performance of your plugin. And if you're fetching several databases with one plugin, you may call them in parallel to save even more time. And we are also planning further enhancements. And just one spoiler here, eventually we will bring the feature of defining custom SQLs to the plugin too. We're still working on a friendly user architecture that is powerful as well as easy. And now I'm open again for questions.
The first question is not for you, Marcel. The first question is for Lars, please. And I mean, the question is Rust? I mean, we are writing a lot of things in Rust nowadays. Is this the future for plugins, or in general, are compiled plugins the future direction we want to take? And I give this to Lars as an answer.
Yeah, I need to think about this. I mean, it always is about what you want to do, in which environments you want to deploy the plugin. Is it only one operating system the plugin is running on? Do you want to have it on multiple platforms? And in this case, the latter was actually the case. Yeah, you want to deploy that on Windows systems, on Linux servers. So it was clear that it needs to be something that can be transported. And on the other hand, it should also be simple to deploy. So, for example, the commonly used Python was not an option for that. Technically, it could also work, but you have all these dependencies, and with Rust, you have that included. So there are actually a few pros for doing that, and of course also cons, because you now have a binary that you cannot easily look into, debug, and something like that. So you need to invest more work in logging, like Marcel told you. So it's always, for us, it's a trade-off, and we'll definitely add that to our tool build and choose that more often. As you have also heard, we did that for Check HTTP version 2, and everywhere where it is about performance and having that installable on multiple systems, we will choose Rust now. That's for sure. But on the other hand, this will not scratch out PowerShell or Python or shell scripts completely. There's always a decision to be made. Too long answer, sorry.
When we started the talk, we said this is the platform for our new database monitoring. And it was the initial goal as well, to be really think about where can we take our entire database monitoring in the future, because we have all these different plugins. And of course, there's the questions now. We have all these things now in MS SQL. When will they end up in the other plugins? And this is something where we basically need your feedback, because I mean, for us, doing it as a binary, handing it out as a binary with all these things, we need your feedback in production, how that works for you. Because if we now do that for all the other SQL-based plugins, we need to be sure that this is the right path for that, and that the architecture we had in mind to basically use this platform and then extend it for other database, SQL-based databases, that needs to work. We think it's the right way, but we really are looking forward to your feedback during Checkmk 2.3, because that will be the basis for our decision making if we roll that out to further databases, right?
Basically.
Yeah. And here, easy question, can we monitor from a Linux machine now, for example, Azure SQL?
Partially, yeah. So I'm not sure how much I should spoiler here, but in the original architecture we planned for the new plugin, we also had a third part in mind. So First part is monitor databases that are running locally on the same server as the agent plugin. The second part is monitoring databases that are outside of the server the plugin is running on. And this obviously leads to this question, and it is a question of can I monitor databases that are running while running the plugin on the Checkmk server, so using the plugin as a special agent, so to say.
I mean, this is actually not the question, but yes, I mean, this goes also that direction.
I was leading to that. And so, yeah, it's considered in the initial architecture design to have it at some point, having the plugin as a special agent on a Checkmk host. We are not there yet, but having the plugin running on Linux is a first step to do that.
So, I mean, you can do it yourself by just basically deploying the plugin on a Linux machine, and the Checkmk server is also a Linux machine, yeah, so you can do it. And I mean, the next step is obviously that we somehow make this possible directly from Checkmk, but that's something which we might consider for a future version. Okay, with that, thank you, Marcel. Thanks.
Thank you.